All right, so probably most of this you've seen before. So how about like a triangle? You've seen this kind of thing before? Let me just draw it on a little bit bigger screen there. So if they give you a triangle, what is that? x3, 8. So question number 1, this is homework. Number 8, number 7 is already on YouTube for you. x3, 8, did I get that right? Yeah, x3, 8. They want you to find x. So how do you find x on a triangle like that? Do you remember? Pythagorean Theorem. Yeah, remember the a squared plus b squared is c squared? Remember that from your earlier math classes? Whenever there's a right triangle. So whenever, right triangle means that 90-degree angle, that little box in the corner. You know that's 90 degrees, huh? Like an intersection or something. When we have a right triangle, you can use the Pythagorean theorem, a squared plus b squared equals c squared. Why is it called the Pythagorean theorem? You want me to write that word out for you? Pythagorean theorem. That will be on the test. You got to get the spelling of Pythagorean right. I'm kidding. I'm not going to test you on the name, but you might want to know it. Why is it called Pythagorean theorem? Yeah. Who is it? How do we use it? When you use the a squared plus b squared is c squared, the only thing, the a and the b, the order doesn't really matter. You just got to be careful about the c. Which one needs to be the c? Yeah, it's called the hypotenuse. Remember all those fancy names? Which is the one across from the right angle, huh? The one not touching the right angle. See how the x and the 3 both are touching the right angle? Right? The other side's called the hypotenuse. That means it's the longest sides across right angle. That's the c. That one's got to be the c. The other two, doesn't matter whether you can put the x first, then the 3, or vice versa. It doesn't matter at all. As long as you got the c right, it's all good. So then just square those. 3 squared, 3 times 3, 9, 8 times 8, 64. How do we solve for x there? What do we do? Subtract that 9. Boom. We've got to get it alone, right? So x squared is, was that 55? Yeah, 55. 55. Now, what do you do to make that into regular x? Yeah, the opposite of a second power is a root. Do you remember that from your earlier math class? And the root will just cancel out the square there. So it's the root of 55. There it is. That's what they want. That's the answer. They don't want a decimal. They want that exact thing, root of 55. They call that an exact, it is, they're right. It's an exact answer. Whereas if you do a decimal, the decimal would go forever. You'd have to round it, so it wouldn't be exact. So that's what they mean. Whenever they say, give me an exact answer, they mean, don't give me a decimal that you rounded, because that's not exact, huh? They just want that, straight, no decimal. Good on that? Remember the Pythagorean theorem? 0.9 bar, 0.95, 0.955 bar, blah, 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 blah. So they want me to, arrange them from greatest to least, biggest to smallest. All right, well, remember what I suggest? Just write them out. A few decimal places, and kind of line them up. It's all about the lineup, right? So I'll do that. So the first one, 0.9. So here I guess I better put it over here. Okay, that's going to be 0.9. It's just going to be zeros the rest of the way, huh? It's just 0.9. Second one, 0.9 bar. Okay. Do that one. I don't know if I have room for all these. 0.9 bar. Well, you know what that means. What's the bar mean on something? Just repeats, huh? Just going to be 9s forever. Yeah. And then next comes the 0.95 bar. So 0.95 bar. So that's just going to repeat the 0.95. 95. I don't know how far to go. I just sort of went a few places, Next one, 0.955. The bar's only on the 5s this time, huh? Right? You see this one? The bar's only on the 5s. So only the 5s are going to repeat, huh? So 0.9, and then the 5s repeat. Like that forever. Okay. Next one. This one is 0.9, and then the 95, the bar's on the 95, so it's 0.9, and then 95, 95, 95. Oh, I got 2 more of these to go. Okay. Let's see, I'm running out of colors here. So, this one, 0.595. So 0.595 bar over the whole thing is 0.595, and on it goes, right? Last one is this, square root of 0.92. I don't know. To me, square root of 0.92, what is that one? Somebody got it? Somebody?
9.
What is it?
9591663.
That's good enough, thank you. So square root of 0.92 is 0.9591630.
It's 6630.
Oh, 6630, thank you. 6630. Okay. Now, with all that said, so remember how you what do they want me to do? They want me to figure out which one's biggest, right? Start with the biggest. So here's the line. Do the lines. This is how we're going to compare, huh? So, first off, which one? Keep the lines here. Keep them all lined up. So, which one's the biggest? 0.999, 0.995. He loses. So the 0.9 bar, this one's biggest, isn't it? So this guy's number one, right here. He comes first. 0.9 bar. You with me? Everybody see how he's bigger? Right? See the first two. Just looking at the first three digits. 999 is bigger than 959 or 955 or 995, right? 999, the blue one, 999, 0.9 bar. He's number one. He's the biggest. All right, who's number two? Let's see, we have a couple of, 995. It looks like the green one. There's the green one. This guy's number two here, 995. Right? Tell me if I missed something. Yeah, that looks right, 995. So what is that one? That's 0.995 bar. He's second. All right, who's third? Just looking at the first three digits there. So we got 999, number one, 995, and then what? Both these guys are 959. Next digit is 5. So the purple one, 959, comes next. With 0.95 bar. The purple one there. 0.95 bar. That one's the fourth one. Followed by the black one, the square root one, huh? Square root is 0.92. All right, 1, 2, 3, 4. How many of these got? 1, 2, 3, 4, 5, 6, 7. 3 more. 3 more. Who comes next? So we're down to 0.959. So 959. What comes after 959? 955. Yeah, 955, the red one. 955. Or is it orange? The orange one. 0.955. Followed by the dark green one, which is 0.9 bar. This one. And finally, the yellow one. The yellow one's last. That's 0.595. So there they are from biggest to smallest. Is that good?
Isn't the 9 the second to last one just 0.9?
Isn't it? What's that?
Isn't it just 0.9?
Yeah, well, so you're right. It is just 0.9. Without any more, that's correct. And how do you say without any more when you need to compare? That means the rest are zeros.
Oh, no, because you already put 0.9 bar.
Oh, you're right. Thank you. I gotcha. You're right. That's a mistake I made. Thank you. So got to get rid of that bar. That's right. I was changing the number. Good. Is that good then? Just list out some decimals. You'll be able to get that one. They're asking the question: indicate true or false. Minus the square root of 9 is irrational. Now, to answer that question, you've got to know what an irrational number is. So let me draw out for you. I'm going to draw what I've already put up there for you, but just to make it extra clear and to have it on the YouTube if you need to look at it later. So basically, the whole box is real numbers. So I'm going to break down all real numbers, and here's how we're going to do it. We're going to break it into two kinds of real numbers. There's rational numbers, and there's irrational numbers. Now, what do we mean? What's an irrational number? Well, I wrote it over there. It's numbers like the square root of 2, the square root of 3, not 4. Square root of 4 would just be 2. I'll get back to that. Square root of 5, square root of 6, etc. What does it mean? It means they're decimals. If you took your calculator and you did the square root of 2 or the square root of 3, you would get decimals that do not repeat. How do I say it? Do not have a repeating chunk. Do not repeat a chunk. Chunk is a technical math word. I'm just joking around. All right, so there's not like a chunk they just keep repeating. So that makes them irrational. So for example, what if you have a number like 0.31 bar, which is 0.313131, right? Forever. That's rational, isn't it? I'm putting that over on the rational side. So if it's a decimal that repeats a chunk, or how about a decimal that just ends, like 0.2? Rational as well. But if it's a decimal that does not repeat a chunk, well, I should add, and goes forever. How about that? Yeah, that's better. So if do you guys have your calculator? Can somebody tell me what's the square root of 2? It's 1.414. What comes after that? Square root of 2? 213. And it just goes on and on. There's no repeating chunk. It doesn't just keep going 4141. It doesn't. It just kind of starts out that way and then just forever without a pattern. Square root of 2. Same thing for square root of 3, square root of 5, square root of 6. Why not square root of 4? Why? Look, I skipped 4, right? 2, 3, 5, 6. Why did I skip the square root of 4? Because it's just 2. Square root of 4 would be over here on the rational side, wouldn't it? That's just 2. That's not a decimal that goes forever, right? So decimals that stop, like 0.2 or just whole number 2, which is 2.0, right? Or a decimal that goes forever with a repeating chunk, 31, 31, 31. Those are all rational. Why? What's this word rational? What is a ratio? See the word ratios in there? What's a ratio? It's a fraction, huh? One thing over the other? A ratio is a fraction. One thing over the other. What do I mean these are rational numbers? But remember from earlier in the class, we learned how to take something like 0.31 that repeats forever, 0.31, 0.31, 31, and write that as a fraction. Does anybody remember that? I know you guys never forget anything we do in here. I'm joking. Does anybody remember? Good job. Good memory. Yeah, it's 31 over 99. 31 over 99. If you did that in your calculator, somebody have a calculator, go 31 divided by 99. You'll get 0.313131. That is it. Remember, if you put it over nines, that amount of nines. Anyway, my point is, 0.31 can be written as a ratio of two whole numbers. It's a rational number. So it's 0.2. 0.2, I don't know if you know, that's just 2/10, or you could reduce it 1/5, huh? 0.2 is just 2/10. And 2, is 2 a rational number? Yeah, it's 2 over 1. Now you think, well, you tell me that this square root 2 number cannot be written as a fraction? It cannot. You cannot write it as a whole number over a whole number. There's no way to do it. It can actually be proven mathematically. It's not that hard. Really, I could show you the proof. You could understand it. We just don't got time for that, so I'm not going to do it. But you can prove that it's impossible to take a decimal that goes forever without a repeating chunk and ever make it whole number over whole number, like a fraction. So you can't do it. You can't make it a ratio. So we call it a what? An irrational number. Get the idea? That's why we give that name. There's no way to write it as a ratio. Whole number over whole number. So if the decimal goes forever without repeating a chunk, those are called irrational numbers. Okay, so getting back over here to the rational numbers, within the rational numbers, as a subset of the rational numbers, we have the integers. integers. Now, what are the integers? It means positive and negative whole numbers. So it's the positives and the negatives. So if you become a teacher of elementary school mathematics, they'll talk about integer lessons. And when they say that, they mean you're teaching them about negatives. That's what it basically means. Integers include the negatives, which is, a new thing. For, I don't know, when they first see it, first grader, second grader, to think about a negative number. There was a point in history, way back, when it was debated whether negative numbers were real. But now we know, of course they are, right? You can have negative temperatures in Minnesota in January. You can have a negative bank account. I've been there, right? Negative numbers are real. The running back on the play can have a loss, negative gain, right? Negative numbers are real, part of real life. Anyway, so integers, it's a subset of rationals. Why? Because every integer is a rational. It's kind of like California is in the United States. Think about that as a big map. If you're in California, then you're in the United States, huh? If you're in the integer box, then you're a rational. You're in the bigger idea of a rational. Why? Because if you're in like positive 3 or negative 4, any positive or negative whole number could be written as a ratio, couldn't it? So it's really a rational. But not every rational is an integer, right? Like 0.2 right here. That's not a whole number. So it's not in the integer box. Really, I should have put square root of 4 in here, shouldn't I? Square root of 4 is actually an integer. Anyway, let me keep going down. And then within that, so within California, you got Fresno County. So in here we have the whole numbers, right? And that's just 0, 1, 2, etc. No negatives, in other words. Get what I'm talking about? That's where you first begin with kids, is you begin with whole numbers. 0, 1, 2, no negatives. Right? So if you're a whole number, if you're in Fresno County, you're in California. If you're in California, you're in the United States. Get the idea? That's how these are related. Right? Every whole number is also an integer. Right? The integers just include also the negatives. The negative whole numbers. And then beyond that, rationals, any number that can be written as a ratio, which includes every whole number, is over 1. Can be written as a ratio. But then the other side is the irrational numbers that may not be written as a fraction, as a ratio. Does that make sense, that layout? Be a good thing to have in your 3x5 card, maybe. So that's the map of how the world works with numbers. Okay, let's get back over here. So, what do you think about square root of 9? Is it irrational? What's the square root of 9? It's just 3. So is it irrational, which means it cannot be written as a ratio? No, it's rational. Just why did I write square root of 3? That was a dumb thing to do. It's just 3, huh? You get rid of the square root when you do the root, right? Probably was confusing you. Whenever I see like many furrowed brows, then I know I'm doing something crazy, and I look back at the board for a minute. That's how it works. So yeah, -3. So that's over 1. That's certainly rational. So they're saying it's irrational? No, that's false. It's not irrational. It's rational. You can write it as a ratio of 2 whole numbers. All right. Next one, they say find the principal square root without using a calculator. I am not going to make you do this without a calculator. You can hit the buttons on your calculator. Anybody happen to know it without a calculator? Or you got it on your calculator already? Square root of 400. What times itself is 400? 20. Yeah, 20. 20 times 20. 2 times 2 is 4, and the 2 zeros. Yeah. Anyway, you can just use a calculator on the test. I'm going to keep moving. Okay. So find 3 irrational numbers between each of the following. Yeah, this one could be a little weird. So look at A. This is going to be a little bit more of an awkward question, I think, for you. Let me help. 5 and 7. I'm going to kind of space them out like that. They want me to find 3 irrational numbers between them. And they're saying, hey, is it these 3, or is it these 3, or is it these 3, or is it those 3? How do we know? Multiple choice, how do we know? Well, let's turn, to help with that, it's kind of a weird question. Let's turn 5 and 7 into a square root. 5 is the square root of what? 25, huh? Right? Just use your calculator if you're a little rusty on some of these times table root things. What square root of what is 49? Square root of 49 is 7. Yes, okay. All right, so there we go. So we basically turn those into roots. So any roots that are between those, is that where these guys are? Where's root 53? No, that's bigger than 49. 53, 62, 63, they're all bigger. They're not between, are they? They're all bigger, so it's not A. Let's go on down to D. I think it's D, isn't it D? Because square root of 41, yeah, that's in between, huh? Square root of 38, square root of 30. Yeah, those are all in between, aren't they? So the answer is D. Would those be irrational numbers? Absolutely. Absolutely. Because any square root that isn't perfectly clean is irrational. Maybe I should write that somewhere. Any root is irrational unless it's a whole number. So it's kind of all or nothing for roots, you know. If you square root 25, it's a perfectly clean 5. If you square root 49, it's just a whole number 7. Otherwise, any other roots that aren't perfectly clean, if they're any kind of decimal at all, they're going to be an irrational number. Any root. So yeah, those are all square roots that are between the square root of 25 and the square root of 49, and they're all irrational. So those are 3 irrational numbers between it. Hey, for a minute, why isn't B right? Look at B for a minute. Why is B not right? Why are all those numbers not between 5 and 7? Which one's a problem? Look at B. Why is B wrong? Yeah, 2.3 is not between 5 and 7. Right? Remember, we're supposed to pick 3 numbers between. So that's why B is wrong, and there's some other reasons as well. But let me just say that one. And then look at D for a minute. D, now those look good, don't they? 6, 6.5, 6.75. Those are all between 5 and 7. Why didn't I answer C? Yeah, those are rational. They asked for irrational. Remember what irrational means? So you think of, I always think of irrational as just crazy, right? Somebody that's irrational is just kind of crazy. That's kind of like what the decimals are like. They're crazy decimals. They're decimals that go forever without repeating. They're just new forever. That's not what these are. These numbers are decimals that end. They don't go forever. Those are rationals. They're not irrationals. That's why C is not the right answer either. Good on that? It gets a little tricky and we don't have a ton of time to spend on it, but I'll do what I can. So we're supposed to pick a number between 5. Wait, I'm confused. I thought it was between 5 and 6. So down here on B, here I'm kind of messing up. Down here on B, you're supposed to go between 0.55 bar and 0.56 bar. And you know what that does, right? That's just 5s forever, and this is 5, 6, 5, 6, 5, 6 forever. And then you're supposed to pick which one of these is going to be 3 numbers in between those. I don't know. Well, between 5, 5 and 5, 6, not 5, 4. 5, 4 is not between 5, 5 and 5, 6. So that one's out.
5, 7.
Oh yeah, this one has 5, 7, huh? That's crazy. That one's out. B and C look kind of good. I don't know. Do you see a difference?
E has 0.554.
Oh, you're right. Look at that. Good eye. Good eye. 0.554. That's smaller than 555. That's not between. Yes, that's just an exercise in super carefulness. Yeah. So C. I'm going to move on. Here, let me show you this one. Okay. So C is between 1/5 and 2/5. Did I do that right? Yeah, 2/5 and 1/5. How are you going to do that? You know what? I looked forever. Not forever. I spent maybe 20 minutes fooling around with this problem and couldn't figure out a nice way. So use your calculator. That's all. I'm sure there's some trick I'm not seeing, but good enough. Just use your calculator. So here's what I mean. Take your calculator, go 1 divided by 5, 0.2. Take your calculator, 2 divided by 5, 0.4. So basically we're looking for decimals between 0.2 and 0.4. Can you get this one on? I just want to make sure you're okay, and then I'll release you. Well, I mean, I'll go on to another problem. Can you guys take your calculator and take 14? So on your calculator, you would go 14 divided by 85 times the square root of 2 equals. And I just want to make sure you're able to get your own decimals for each of these. So 14 divided by 85 times the square root of 2. What is it going to be? 0.2 times 1.2. I don't know. It's going to be like 0.2 something. 0.2 or 0.3. I don't know. Somebody got it?
0.2329.
Yeah. And then does it keep growing?
Yeah, it's like random.
Yeah, because we know it's irrational, huh? It doesn't keep going with the 2,9 because it has a square root, huh? Everything with a root varies forever, random and forever, yeah. Yeah, is everybody able to get that on your calculator? So you would just get that one, and then get the next one. Whoops, get the next one, and see if they're between 0.2 and 0.4. So far, so good. That number is between 0.2 and 0.4, isn't it? It's bigger than 0.2, smaller than 0.4. You with me? Maybe part A is the answer. Let's try the next part. Can you get this one on your calculator? Somebody got that? What's 37 divided by 170 times the square root of 2 hit equals? What's that one? Might be too small. I don't know. I can't tell.
1.4.
Oh, too small. 1.4. So that one's not between 0.2 and 0.4. So the answer is not A. You with me? See how to do this? You guys, is everybody getting that 1.4? Okay, 1.4, whatever. I know it's random forever. Right? So you're supposed to find which of these has three numbers between 0.2 and 0.4. It's got to be between 0.2 and 0.4. Well, 1.4 is not. So the answer is not A. Go on to B. So it's going to be tedious. You got to figure out all the decimals, see if they all come out between.
I didn't get that for that one.
No? Some are not. Some are not. Yeah. 0.30, 0.3077. It's just easy to hit a wrong button. Something small. Is everybody able to get that on that?
It's sometimes you hit the equal sign twice. If not, you'll get just that part.
Oh, what is it?
Sometimes you have to hit the equal sign twice when you're doing it.
Okay, it depends on the calculator. They're all a little bit different. Yeah, sometimes that's true. Equal sign. If you're having any trouble getting that, grab me after class. Because they're all a little different. There's not really much I can say to help everybody at once. All the calculators are a little different. So grab me after. Be glad to help. Yeah, sometimes something little like you're saying. Jesus, just something small like that. Be glad to help you. Yeah, so that one actually is between, isn't it? Maybe this is the answer. Let's try the third one. Is that one between? 23 over 85 times root 2? No, it's going to be too big. It's like 0.4 something. Oh, it works? 0.38, blah, 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 blah. Well, that's it then. The answer is A. Right? All three numbers, I got the 0.23, the 0.30, the 0.38. They're all between 0.2 and 0.4. So A is the answer there. All those decimals came out between 0.2 and 0.4. The 0.23, the 0.38, and the 0.3077 all came out between 0.2 and 0.4. So just use your calculator on that one. Let me move on to number 6. All right, so now they're saying square root of 11. You can see it over here. There's a lot on that page, I know. Square root of 11. And they basically want you to say which categories it's in or not in. Does that make sense? We're thinking about the big map here now. So square root of 11. So if I was to draw the big map, so here's the map again. This is question number 6. Well, square root of 11. So here's the big map. Remember this is like the whole world, real numbers. And then over here are the rational. Over here, the irrational. And then within the rational, we have the state of California, integers. And then within that, we have the whole numbers. So, where would we put square root of 11? Let's just do it on the map first off. Where does square root of 11 live? First off, is he rational or irrational? square root of 11?
Irrational.
Yeah, because the square root of 11's got to be over here because he's not a clean decimal. He's not like square root of 9, which would be 3, which is perfectly clean. Remember what I said? Any square root, if it's not perfectly clean, is irrational. So if he's irrational, then he's on this side of the map. No way is he's not an integer, he's not a whole number, he's not rational, he's not anything on the left. Does that make sense? So we go back and we say, is he a natural? No. Is he a whole number? No. Is he an integer? No. Is he irrational? No. Is he irrational? Yes. Is he real? They're all real numbers. They're all under the title real numbers. That'll always be yes. So there we go. I didn't mention what natural numbers are. It doesn't really matter. The whole numbers include the 0. They include the whole, if that helps you. Remember, I'm not going to test you on this. This would be dumb. But I'll mention it anyway. The natural numbers are the same thing. They just don't include the 0. It doesn't matter. Some people call them the counting numbers. Whatever. Same thing. So it's not a big deal. Counting numbers or natural numbers, they start at 1. Whole numbers have the whole. They start at 0. They're the same thing, basically. They don't have decimals, in other words, right? So not a big deal. I'm not going to test you on that. All right. We good on that, though? Generally, that plan? All right. Now, number 7, root of 75. Let me write that for you. They're saying, take the square root of 75, and this time they don't want a decimal. They want me to simplify it like you may have done in algebra. How do you simplify the square root of 75? Do you remember that from your algebra days? You got kind of do like a little factoring tree down here. You say, just take calculator. What divides into 75? Think about money. 75 cents. That's 3 what? 3 quarters, huh? 3/25s. And then break down 5 times 5. So break down the 75. So in other words, 75 is 3 times 5 times 5. Good so far? That's just the breakdown of a 75. Now, what do you do with the root when you got stuff inside? Do you remember from algebra? Yeah. Are you meaning like square root of 3, square root of 25? Excellent. Yeah, that's right. And then what's the square root of 25? 5. So it's root 3 times 5. Usually we put the whole number in the front like that, huh? 5 root 3. There we go. Yeah, just break it into 2. Exactly right. Good. So that's 5 root 3. Okay, so let's use your calculator again. This time we have a 3 in the hook. That's a little different. What do you know? When I look at 625, it's okay if you don't know everything about it right away. What do you know goes into it just by looking at how it ends? 5. Probably 25 even. For sure 5 though, right? Because it ends with a 5. So just take your calculator and divide by 5. You'll get 125. And then you look at that and you go, oh, it's got to be another 5. That's 5 times 25. And then the 25 is 5 times 5. So there we go. So what does that mean? We have the cube root of 5, 5, 5, 5. 4 5s. Okay. Now, how do I simplify a third root like this? A cube root. Does anybody know? How do we do it from there?
Since there's at least 3 5s, you can take 1 5 out.
Yeah, Alyssa, right? Yeah, good memory. Basically, when I teach algebra, what I teach my students is say, look, it's like going to Target. Things are on sale 3 for 1. The little number in the hook there is like a 3 for 1 sale, meaning 3 5s come out as 1, they're gone. It's what it does. The number in the hook is like the sale. It's a 3 for 1 deal. So out comes the 5. These guys are all gone. What's left in the hook is the other 5. That's the answer. 5 cube root of 5. That's what is that okay? Are you seeing that? So, whatever number is in the hook, that's the deal, like a 3 for 1 deal, right? If you were buying 3 items at Target and they were on sale 3 for 1, you'd go out of the store only paying for 1, right? So that's what the number in the hook does. That's really what we did back here. If I go back to this last problem, that's what we really did here. I just didn't say it that way. What do I mean? What did we do? We did the square root of 3, 5. Let me bring it down here like this. And what's in the hook there? That's called a square root, isn't it? What's that means in the hook? 2 squared. This is called what? X2'd? It's called x squared. Now, square is a word for 2. What's the word for 3 in math? Cube. Cube for 3, square for 2. So when we call this thing a square root, and we call this one a cube root, we're saying the number 3 is in the hook. We're saying the number 2 is in the hook. So there's really a 2 there, isn't there? It's an invisible understood 2. So same deal at target. 2 for 1. 2 5s in, 1 5 out. They're gone. It leaves the 3 in, which is what we said the answer was. We just didn't need to show the 2 because it's understood if you don't show any number in the hook that it's 2. See, it's the same deal. That's what roots do. Whether it's a 2 or a 3 or whatever, it's always what roots do. Good on that? They want me to solve this equation for x. This is pretty tricky. So I would just take my calculator out and just start going 3 times 3 times 3 until you get 81. Just start multiplying. So how many 3's does it take to get 81? 4 of them. So what does that x have to be? What power do you need? 4. So x has to be 4. Is that good? Does that make sense what I did there? We have time for one more. Let's do part B. Yeah, B's tricky. So we go to that one, part B over here. 9 to the minus x is 243. So, how are we going to do that one? If you take your calculator on this one, and you take 9, you go 9 times 9 times 9, you'll skip right over the 243. 9 times 9 is 81, times another 9, you're in the 700s. So you skipped right over it. So this one's more tricky. Yeah. Yep. So I'm going to have to I'm going to have to finish this one on YouTube for you. So I'll do that. Let me just pause there. Okay, so to solve this one's more tricky. We're going to have to make the two bases the same. Because on your calculator, if you take 9 times 9, you get 81. And if you do a third 9, you get, I think it's 729. So we skipped right over the 243. We're not getting the 243. So what are we going to do? It's not like the part A there. So what you have to do is you have to rewrite 9 as 3 squared. And take your calculator for 243 and just start multiplying a bunch of 3's. And I think you need, isn't it 5 3's? Yeah, 5 3's. So this is 3 to the 5th. So you have to make the bases the same. That's the tricks. And now, you think, well, what about the rest of it? Yeah, the rest of the stuff is still there. The negative x is still there, Is that good? So I just changed the 9 to be 3 squared. And the 243 to be 3 to the 5th. Okay? What? Okay, great. So what? Now what? So I made the basis of step 1, make the basis the same. Then powers must be equal. So after you've set the bases the same, the powers have to be. What do I mean powers? I mean right up here. Just the power. Forget about the 3's now. Just forget about the 3's. 2 times negative x must equal 5. The powers must be equal. Why? Well, because the bases are the same. If I said, hey guys, I've got 3 to some power and it's equal, same as 3 to some other, call this A, call this B. 3 to some power, call it A. And 3 to some other power, call it B. And they're coming out equal. A and B must be the same. If A and B were different, if this was like 1 and this was like 2, no way 3 to the 1 would equal 3 to the 2. This would have to be 2 and 2. Or some same number. A and B have to be the same number. So once you've made the bases the same, because these things are equal, the powers have to be the same or they wouldn't be equal. Right? So once you've made the bases the same on step 1, they're both 3. Then you can just set the powers equal because they have to be equal. So now how do you solve that equation? I want to solve that equation for x. So let me take this and rewrite it. Positive 2 times negative x is negative 2x, isn't it? Right? Positive times negative is negative. Now how do you get x alone there? X going to want to be alone. Divide by negative 2. Boom. X is negative 5 halves. You can put that negative in the front, bottom, top, front. Doesn't matter on a fraction. Negative 5 halves is the answer to that problem. That means if you went back up here and you put in that x spot negative 5 halves, you could check it on your calculator. It would 9 to the negative, which would be positive 5 halves, is 243. You could check it on your calculator. It's the right answer. Okay, part C here. This one's super tricky as well. These are really tricky problems. Take your calculator. Look at 243. 243, if you break down 243, you know 3 goes in. That'd be 81, and then that's 9 times 9, 3 times 3, 3 times 3. So 243 is 3 to the 5th power. Now take the 3125 and break it, and you know 5 goes in. 5 times, I think it's 625, and 5 goes in again. 5 times 125, 5 times 25, 5 times 5. 1, 2, 3, 4, 5. So 5 to the 5th. So we broke down the 3125 and the 243. Now, let's get tricky. Let's bring this over here. So we have 9 25ths to the 3x. Kind of move that over. And that's equal to this, right? And in fact, I could rewrite that as 5/3 to the 5th. Since they're both to the 5th power, I can just put parentheses, can't I? Like that? Okay, so I got the left side, I got the right side cleaned up a little bit. Now what? Well, that left side, actually, I should have done something on the left side. 9 and 25, you can break that down, right? 9 is 3 squared and 25 is 5 squared. So we have 3 squared over 5 squared. Okay, so what? Well, that means it's 3 over 5 squared. Let me clean that up a little bit. This is, oops. Like that. So it's 3 over 5 squared. You see that? 3 over 5 squared is 9 25ths. And the 3x is still outside there. I know this is a tricky problem here. Okay, now what? Well, the last trick, and this is a pretty big trick, is remembering how you get a fraction to flip. See how these guys are upside down? I remember, what am I trying to do? I'm trying to make the bases, step 1, make the bases the same. They're almost the same now, but they're upside down. What do you do about that? I don't know if you remember from algebra, but if you have a fraction like 2/3 to a negative power, it flips it upside down. Negative powers flip, and then the power becomes positive. It flips it upside down. So if I just take this guy and flip him upside down and make that power negative like that, it's right. So you see, I just took that 5/3 and I flipped it upside down to be 3/5, but I changed the power to be negative. I know that's pretty tricky. It's a tricky algebra maneuver there. Why am I doing it? Because I want to make these bases the same now. Now the bases are the same. And once you make the bases the same, the powers are equal. So this power must equal that power. 2 times 3x must equal negative 5. Just forget about the bases at that point. Remember, like we reasoned on the last part right here, once we made these bases the same, you can just set the powers equal. Same thing here. Once we make these two bases exactly the same, just forget about them and grab the powers. The powers have to be equal. So that means 6x is negative 5. Last step to solve for x. Divide by 6. There's our answer. Pretty tricky problem. Okay, so here on part D, I've got square root of negative x is 3 root 5. I want to make that into plain x. What can I do to get that root off of the negative x? Well, you probably remember from algebra, if you 2 power it, and whatever you do to one side, you have no choice but to do the same thing to the other. You got to 2 power both sides, and the 2 power and the root cancel each other out. Like that. And negative x, right, that just gets rid of the root, doesn't get rid of the negative. The 2 power just canceled out the root, they're gone, and you just have negative x. On the other side, you got 3 root 5 times 3 root 5, right? 2 of them. So what does that do? 3 times 3 is 9, and square root of 5 times square root of 5 is square root of 25. They go together under one root. And what's the square root of 25? Plain 5. Like that. And that's 45. Last step to get x alone. Divide by negative 1. X is negative 45. Pretty tricky. Okay, so now in this one, again, I want like regular x, normal regular x. How can I turn such a weird power into normal regular x? Well, normal regular x means x to the 1, doesn't it? There's invisible, understood, positive 1 in the power. We don't show it, but it's really there. That's what normal x means. X to the positive normal 1. How are we going to get that? Well, what power could I put up here? If I put negative 25 thirds, you see what would happen? The 2 negatives would multiply. These 2 negatives would be positive. The 3's would cancel. The 25's would cancel. The 2 negatives would make positive 1. But whatever you do to one side, you have no choice but to do the same thing to the other. And then that's just our answer. 5 to the x, regular x, to the 1 is 5 to the negative 25 thirds. Okay, so now we want to get x alone. How do we get x alone here? Again, you have to do a square root, but here's a trick you might not remember from algebra. When you put a square root on both sides, you have to put plus or minus. Why? Well, think about a simple little equation for a minute. Let me prove to you why you've got to put that plus or minus. If you take x squared equals 9, and what could you plug in there? What makes that true? 3 and negative 3 both make that true, don't they? Negative 3 squared is 9, and so is positive. Positive or negative 3 squared is 9. Both answers work. Both answers are true, aren't they? Well, that's why you need plus or minus. You see, if you just put the root, you're only going to get the 3. So you got to put plus or minus, so you get both answers. Both are really answers. Plus or minus 3 squared is 9. So when you put a root on both sides, you've got to put plus or minus. I have a dorky saying to help my algebra students remember this. I say when you put a roof on the house, like a root, it's kind of like a roof, it's dorky. Put a roof on the house, you got to go up and down the ladder. Plus and minus is kind of like my up and down. So I just try to help them remember when you put a root on both sides, you got to go up and down the ladder, plus or minus. Okay, so getting back over here, I put a root on the house, root on both sides, you got to go plus or minus whenever you do that. Okay, the root cancels the square, and we get x minus 1 is plus or minus root 5. You can't simplify that root 5. What do we do now? Last step, add 1 to both. This is an equal sign, right? So it gets rid of that, gets x alone. It's plus or minus root 5 plus 1. That really means 2 answers. That's plus root 5 plus 1, comma, minus root 5 plus 1. It's those 2 answers. Okay, so last question. 2 to the 10th times 16 to the t. What happens when t is 0? So down here, if I take 2 to the 10th times 16 to the t, and they're saying put in t equals 0, please. I'll get 2 to the 10th times 16 to the 0. Now, what's anything, I don't know if you remember from your algebra days, but anything to the 0 power, any number to the 0 power equals 1. It always equals 1. So this is 2 to the 10th times 1. It's just 2 to the 10th. So the answer here is just 2 to the 10th. They want exponential notation. They want you to leave it just like that. Don't get 1024, which is what the number would be if you did it on your calculator. Just leave it 2 to the 10th. Let's go on to part B. So part B. Now they're saying 1/4 of an hour. T is the hours, notice. So in part B, I'm going to take the formula 2 to the 10th times 16 to the t, and I'm going to put in for t 1/4. Right? 1/4 is t. 1/4 hours. So put in 1/4. Now, what do we do with that? What's a 1/4 power do there? Well, a couple ways we can do this. You can, what it is they want you to remember that a 1/4 power is actually a 4th root. I don't know if you remember that rule from algebra. The denominator swings around and goes in the hook, and the 1 just stays right there. So the 16 to the 1, and the 4 swings around into the hook. It's the 4th root of 16. Okay, so what's the 4th root of 16? Well, if you break the 16 down, 16 is 4 times 4, and each of those is 2 times 2, 2 times 2. So you get 4 2s. That's the breakdown of a 16. 4 times 4, and each of those is 2 2s, 2 2s. Okay, so you get 4 2s, and then remember how square roots work? It's a 4 in the hook, which means it's shopping at Target. It's a 4 for 1 deal. 4 2s in ships 1 2 out, and they're gone. So it's bring it out here. It's 2 to the 10th times 2. This root is gone because there's nothing left in the root. If there was something left over, the root would stay. But everything left the root came out as a single 2 because that's a 4 for 1 deal at Target. So it's 2 to the 10th times 2. Can we simplify that at all? I don't know if you remember the other rule. This is really 2 to the 1. Remember, powers add. That's 2 to the 11th. Powers add. Because 2 to the 10th, what does that mean? 10 2s, 3, 4, 5, 6, 7, 8, 9, 10. And then that last 2, so there's 10 2s and one more, there's 11 2s. That's the answer here, 2 to the 11th. Let's try part C. Now, part C is going to be very similar. Now we're saying half an hour. T, right? T is the hours. Half an hour. So they want me to take the formula. 2 to the 10th times 16 to the t. And they want me to put in the t as a half hour and simplify that. Well, what did we just learn about what a fraction in the power zone means? That 2 swings into the hook, doesn't it? Just like the last one did. So this is 2 to the 10th. They're just reminding you of these algebra rules. So the 16 to the 1 stays put. The 2 swings in the hook. So that's the square root of 16. So let me simplify that. And what is 16? Remember, it's 4 times 4. And each of those is 2 times 2, 2 times 2. So that's 2 times 2 times 2 times 2. And then what happens? This is a 2 for 1 deal at Target. 2 2s in, sends 1 2 out, and they're gone. 2 other 2s in, sends another 2 out, and they're gone. So we end up with 2 to the 10th times 2 times 2. 2 2s make it out because that was a 2 for 1 deal, right? The 2 here in the hook said 2 for 1 deal. 2 2s in, sends 1 out. 2 2s in, sends 1 out. The root's gone because there's nothing left over in the root. If there was anything left over, so if there was like another 3, then I would still have the root of 3 there. But there was nothing extra left over in the root. Everything left the root. So it completely vanishes. Okay, what does that equal then? Well, I'm bringing it over here. 2 to the 10th times 2 times 2. That's 2 to the 12th. The 1 and the 1, they add 2 to the 12th. Because that's 10 2s, another 2, and another 2. It's 12 2s. And there's the answer.